So, hello, Diana Montalion. Um, we build up a bit of tension for the main act on the center stage, of course, like in every big rock concert, and you are now our main act. So that's the extra 5 minutes. Great to have you here. You already gave a workshop on Monday about learning system thinking, and this will also be the title of a book you are currently writing, and I think should be available in summer 2024, right? Uh,
Yeah, spring, hopefully.
yeah.
Hopefully. Yeah.
Spring. I read that O'Reilly, they could think a bit more conservative. They say August it will be there.
Do
But
they?
now
Ooh.
just and now, but yeah, now you're talking about the iceberg and how not to hit the iceberg. When I look outside the window, there's a lot of snow there. Luckily, no icebergs here, but especially for the architectural model with the iceberg, the tip of the iceberg you see, and then what's down below, and that is your topic for the closing keynote. I'm looking forward to, and since we already lost 5 minutes, I leave the stage to you now, and I'm really looking forward to this closing keynote.
Well, thank you. And yes, we had some technical difficulty, and this will shock everyone in this room. But the solution was to turn it off and turn it back on again. And then it worked. And I really love how often that's the answer. So as you said in this lovely introduction, I'm Diana Montalion. I'm a systems architect and founder of Mentrix Group. And because it feels strange to me to just introduce myself with my resume, I will also introduce members of my family that I live with. This is Theodore Roosevelt, Winston Churchill, and Maximilian Robespierre. And I bet you can guess who thinks they're in charge of everything. So, we're going to talk today about this shared experience of moving from software to systems of software, and some of the things that experience, both good and not so good, have taught me, and what I recommend to help support this transition. So I began as a back-end engineer and helped build the software monoliths, especially digital information software. And it's still a marvel of engineering. I really have nothing against the work we were doing, because it was really hard at the time to solve some of the problems that we needed to solve in order to scale. But meanwhile, the world was changing around us, and that we were building software as a destination to share information via the web, for example, or something that you download and use it as a tool. So, Microsoft Word as software. But then software was becoming so ubiquitous, it was everywhere. Right now, most of us have software in our pocket. We have software that provides infrastructure for other software. So the relational complexity of information systems and of software was increasing around us. And we were trying to scale to meet those evolving and emergent needs. And so I was part of architecting a few big digital transformations to respond to this changing paradigm. And in the end, the whole situation looked more like this. And so I became very curious. Why? Why were we hitting the iceberg and sinking, these initiatives sinking? And the answer was never, we don't know enough about Kubernetes yet. The tech part was certainly part of the challenge, but what was happening in the tech mirrored the structure of our thinking. And that structure was not supporting the type of transformation that we were trying to do. And increasingly, this was my life. I am that person in the doorway trying to translate complexity to those who were engaged in the feature-driven engineering that we were so used to. And so I, out of necessity, became interested, what does that person need? And as a systems architect, I really needed to understand, because increasingly that was my role. I couldn't solve everything with code. And one of the things that stood out to me is that we were doing a lot of changing what we think as quickly as we could, but we weren't changing how we think and how we communicate. And that often that was holding us back. We just really didn't know how to change. So we are all taught in school from the time that we're born, but also taught as software engineers. We are taught and trained to think linearly. We practice reductionism. We take something that's complex and we break it down into interrelated parts. We need linear thinking in order to build software and in order to organize ourselves. So it's necessary. The challenge is that it's how we structure everything. When we think of thinking, we're usually thinking of linear thinking, and it is only one type of thinking, not necessarily the way to structure all types of thinking. So our our linear structures and our ideas about how to communicate our core beliefs kept producing silos. So Conway's law says that organizations who design systems will produce designs that are copies of the communication structures in the organization. And this makes sense, right? That there's nothing in production that isn't a result of what we thought and what we talked about. And so we were trying to transform without changing these structures in any meaningful way. We were changing them, but we were still changing them sort of inside the structure. And so Pirsig says, if a factory is torn down, but the rationality which produced it is left standing, then that rationality will simply produce another factory. And this was my experience the first time that we moved from monolithic software to designing and building microservices. Our first attempt was a pretty tightly coupled distributed monolith in the cloud, even though we really did work hard to change our rationality. But it took us a few tries to really understand how to shift the way that we were thinking and the way that we were structuring work and communication to exist in this new paradigm. And I'm going through it again now, where I'm working in a technology in Flutter and Firebase. These are new to me, and there are times in which I get stuck, and I get stuck because I'm trying to do things the way that I did them for the web, and in an app, it doesn't translate. The context is different, permissions are different. So this is something we're experiencing, this changing rationality throughout our careers, if we're lucky. I think that's I think it's the fun part. So I am, and we are collectively expanding our skill set. So we know how to make silos. We're really good at that. We're good at making silos, but we also understand how to analyze and how to plan and how to break things down into parts. But what we're also needing is to be good at the things that are on the right side in this model, being able to design for emergence, meaning that when you have that the sum of the parts is greater than the individual parts together, that you get something from relationships, to be able to think about interconnectedness, to be able to synthesize knowledge and information. And so this process became and is becoming, I think, a core skill for us as relational complexity is increasing. And so Pearson goes on to say that the true system, the real system, is our construction of systematic thought itself, of rationality itself. So keeping in mind, We've made all of this up. Agile architecture, Kubernetes, Kafka, microservices, value streams, and we have made this up, and we're also evolving all of these ways of structuring thinking. And so, how do we reconstruct systemic thought? Like, how do we do that when we're trying to transform software systems? So, what was so wonderful for me is that I was talking about hitting the iceberg, feeling like I'm changing seats on the Titanic before I began diving deeply into systems thinking. And the most common thing you'll see if you Google systems thinking is the iceberg model. And for me, this did a wonderful job of giving me some vocabulary, a framework to start talking about what what I was seeing and what we were seeing and what my teammates were seeing. And there's a lot of pushback on architecture, systems architecture as too abstract. We want things to be concrete, Diana. We want concrete. But in fact, it's a misunderstanding. It's diving deeper. It is looking beneath the surface of events to the patterns and trends that are happening over time, always about time. And it's looking at the ways that we've structured our thinking, communication, and the software itself and the relationships between software that keeps these patterns happening. And underneath that is whatever belief that we truly believed was the right thing to guide us in the direction we were going. And that when you make a significant change to a system, if you only change events, patch a bug in production, you don't actually change the system as a whole. The patterns and trends will reemerge. The structures will push everything into the same direction that it was going. A factory will become another factory. So this is just one of many tool set. And today we're just going to touch very lightly on some of them because this is really a lifelong practice. But it's not a silver bullet. There are many ways of doing it. But here are some practices. In this talk, we're going to talk about some of the practices that can help, some places to start, right? So that what we begin to look at is redesigning our system of thinking. And most importantly is recognizing that you can't separate how people think and communicate and behave from what we push to production. So the iceberg is realizing that everything we build mirrors our core mental models. And if we want to build something different, then we need to think and communicate different core mental models. And this sounds very straightforward. The iceberg model is pretty easy to understand. But in fact, in practice, it's incredibly challenging. And one of the things that it begins with, which is often the hardest, they say the first step is the hardest, is accepting that we don't have as much power and control as perhaps we thought we did, or perhaps we think we need. Our effort to command and control is sometimes what is holding us back. And as we move into systems thinking, we move into continuous learning. That understanding that uncertainty is always part of the equation, and that we create a system of practices and support for those practices that improve our capacity to handle relational complexity. And because they're challenging, it is a lifelong practice. But also, the more you practice, the more you know you don't know. Like, that's one of the wonderful paradoxes for me about the complexity of emerging software systems, is that they're hard. It's hard. This is hard work. And the more we do, the more we want to be able to continue to evolve. So there's no destination. And the challenge is that we're terrible at systems thinking. One, because we're not trained to do it. Two, because we're not supported to do it. The gravity in organizations will pull back into silos, back into reductionism. And then also because it's hard, it's difficult to do. And it requires skills that we might not think of as tech skills: patience, thoughtfulness, insight, continuous learning. And so we're taking a great first step when we go towards expanding our thinking tool set by accepting that we are also expanding our definition of tech skills, which means over time we're also expanding our definition of the ways that we build teams and the kinds of skills that we prioritize. So how do you improve your capacity to handle complexity, uncertainty, ambiguity, inquiry, so that we're able to do hard things? And Fred Brooks in the Mythical Man Month says that conceptual integrity is the most important consideration in systems design. So our goal is to get better at this. And what this means is that our ideas design our systems. When our ideas are cohesive and they are in good relationship to each other, when they have flexibility and emergence and the kinds of things that we want in our technology production, we design better systems. And conceptual integrity needs to exist between people before it can exist in the technology systems. So when we create cohesion in our thinking process, we create cohesion in what we produce. And this is kind of a chicken and an egg assertion, because the software is teaching us what it needs, how to think, and also we are designing it and changing it through our thinking. And so the software and the way we think about it and talk about it come to resemble each other. So we also try and make alignment. We try and have everything linear and controlled. But this is about integrity. Conceptual integrity is about good relationships between software parts. And I want to caution you against a very common trap before I give you the five practices. And that is that a lot of organizations have come to realize that they need this. And what they're doing then is they put someone in a role, like an architect, whose job it is to bridge gaps, to keep thinking somewhat cohesive between teams or between circumstances. And we can call these glue roles, trying to glue and hold thinking together. And you may have experienced this. I certainly have many, many times of having a discussion. Everyone seems like they're on board. And a week later, everyone has wandered off into disagreements and political wrangling or forgotten this piece. And this would happen all the time. It's what we call cat herding. So then more managers, more project managers are brought in to manage thinking and create alignment. Now, this is temporary. It's a Band-Aid. The glue doesn't hold. Organizational gravity will pull it apart. It also is a very exhausting role to play. And so it can end up being a very Sisyphean type of role. And what we're really trying to do is facilitate this change in everyone. Everyone benefits when everyone cultivates these five practices, because everyone contributes to a systems architecture, because everyone is in the communication structure. So these practices apply to whatever role you might play to make systems design easier. And you can choose the things that you prefer more than things that you don't, because what we're always doing in systems is creating partnerships, is sharing our skills and working together so that a group of people are greater than the sum of their parts. So the first practice is to look for leverage points. I don't know why I can't say that word today. We tend to be requirements driven. So we describe a change that will delight the user, for example, and we build it. And this is a good thing. But the failure to delight the user can often be a symptom of a systems problem, not a failure of understanding requirements. So we're working then at the surface of events. And when we're looking for leverage points, we go deeper. So we're looking for places to intervene in a system where a small shift in one thing can produce big changes in everything. So, in my world, this usually lies in the way that information is shaped and structured and the way it flows across the system. So, often people are focused on products and the software that supports them, which is important. But the leverage point exists in the information flow and the ability for information to change according to the context in which we're wanting it. So information, a very simple example is information that's consumed via a web browser, doesn't translate easily into a "Hey Siri" answer to a question. So increasingly, we're designing for. Okay, I found. Ha, when I said it, my phone is now talking to me because she thought I was talking to her. Funny, I shouldn't have had it in the room. Anyway, so increasingly we're designing for context, and context is always changing. And small very rarely means easy. If it was easy, we would have done it already. So discovering and shifting a leverage point will almost always require cross-functional effort. It will require different points of view working together to understand how to make this shift. It will rarely be a change that can only happen in the technology architecture. And there will always be gravity holding the current situation in place. Jay Forrester is one of the leading systems scientists and from MIT, and he invented the beer game, which is another thing that we could really, I encourage you to Google and look. It's a very good systems lesson. But he says that people who know a system will often intuitively find where the leverage points are. He goes into organizations and asks people about what's going on. And often they're aware of where the stuck places are, but also they're pushing it in the wrong direction. And I've seen this many times in my career, and I'm sure you have too, where an organization is trying to solve a problem, but inadvertently making the problem worse. And this is actually probably somewhat unavoidable in that we will usually come up with some wrong answers before we come up with some right answers, which is why continuous learning is so important to supporting our thinking process. That teams and people and organizations, they need to have some experience in order to really understand what the best thing to do is. And that leverage points will be more impactful the further down the iceberg you go. So changing a mental model will have more benefit than reacting to events. And when I talk with people about systems architecture roles, they usually aren't describing this. And this is why I really encourage us to think about how we can expand our definition of this skill set so that we have more ability to dive deeper to where the true power lies, where we actually have more ability to have a positive impact in the changes that we make. So I'm going to give you 3 examples. So Donella Meadows in her book, Thinking in Systems, gives a list of 12 places to intervene in a system in increasing ability to impact the system. So I'm going to give you 3 examples in our world in order of increasing impact. So the first is the one we most commonly do, which is increase the size of storage or the speed of responses. Also, when we change parameters, like having auto scale or 5 nines, make something faster, make something more responsive to changing circumstances, adding caching. These are leverage points, so they matter to do. They aren't the highest leverage points that we can choose, but they do make a difference in the system. And at the next level is the way that we design feedback loops. So in systems, positive growth and expansion, more users, more speed is self-reinforcing, right? So if you have more users, that will attract more users. But this is also how systems become chaotic and they collapse if unchecked by constraints. So we do tend to focus on constant positive change, but in systems, positive change is very disruptive over time unless the system as a whole can evolve with the change. So negative feedback loops aren't negative in a bad way, they're self-correcting, right? So we can think of tech debt like this, right? So you keep adding code and you keep adding code and you keep adding code until you have a big ball of mud, and you will always have a big ball of mud because positive unchecked growth always creates chaos. So if you can slow down the growth to enable the entire system to mature along with the change, then you avoid this imbalance that will inevitably happen. So you want to create feedback loops with this in mind. Like rather than strictly produce growth or so what happens is we have lots of growth and then we also have lots of lockdown of security, and we have a frail system that we have to defend with, it feels sometimes, with our very lives. And these are just two sides of the same coin. They're interrelated. And then the most impactful one is to change the mindset out of which the goals, structures, rules, and workflows arise. So this is why for a lot of people, DevOps practices could be very transformational because they didn't just change the tech, they also changed the structure and the rules and the workflow. If we're going to do a digital transformation, this is part of it. This is part of the digital transformation. You can't transform without changing the paradigm. And this is something I think that we're still really figuring out how to do, and it's hard to do. So number 2 is to be excellent at systemic reasoning. So what do you do? How do you decide, communicate, architect when there is no right answer? You need to take sound action, but you can't be sure what will happen. And I would say this is like we can rarely be sure. We've kind of convinced ourselves that we can know exactly what will happen, but in fact, we're surprised more often than not with the kinds of impacts that change has on a system. And so we can still plan, we can still try to know, but also we can take better risks using systemic reasoning. And technology culture is, in my experience, very opinion driven. So we have opinion driven decisions. And I love opinions. I mean, I have lots of opinions. There are a number of things you can ask me about, and I would be happy to share my opinions with you. But as knowledge workers, opinion is not the way to share our authority on a topic. It's insufficient, especially as complexity increases. So we need to share the reasons that convinced us. I am not just going to give you my opinion. I'm going to show you how I came to this conclusion so that you can decide if my construction of systemic rationality is cohesive, is sound. Are my reasons good? Am I misinformed perhaps about some of the ways that I got there? And when you try and give the reasons that support your ideas, actions, or theories, you discover that your reasoning is not as sound as it seems to you in your own mind. So for knowledge workers, this is an excellent practice to improve our thinking. So we're synthesizing knowledge and experience, our own and other people's. We're using sound judgment to help prioritize what matters in this circumstance. And we're giving recommendations that are based on valid reasons. What are the reasons that support my ideas or my recommendations or the action that I'm taking? And have I considered it from other points of view? That I find that one of the things that holds technologists back is that they're often only thinking about the technology, and they only are thinking about the technology from one view of the technology system. The better we get at synthesizing other points of view, the stronger and more cohesive our ideas are likely to be. When we're architecting ideas or actions, then we're engineering them by constructing sound reasoning that reflects a holistic understanding of our circumstances. So rather than give an opinion, I'm recommending to expand, you share your ideas, your actions, your theories, and give 3 to 5 reliable, relevant, sound, and cogent reasons that justify your idea, action, or theory. Show me how you came to that conclusion. And include in it a clear description of why this idea is highly impactful to the system as a whole and why it matters today. One of the challenges I've always had on engineering teams is we know something is very important to do, but the people that are making budget decisions everybody's telling them how important it is to do all the things everybody wants to do. And so it helps to become really good at being able to connect a change that you know is valuable with the impact that it will have for the organization and why it is the highest priority to pay attention to now. And then include other people's relevant point of view. It's our opinion when it's our own, but it becomes systemic reasoning when 3 or 4 of us have worked together to come up with strong reasons for going in a particular direction. So the third is practicing metacognition. You can improve your thinking or evolve it if you aren't aware of your thinking. Well, metacognition is critical awareness of your own cognitive patterns, emotional reactions, cognitive biases of your opinions. There's nothing wrong with these things, and all of our minds are going to have these gaps in cognition. And we've been taught to focus on what we know, and we're tested on what we know. But as knowledge workers, how we think, experience, and learn that's our asset over time. That's what we are maturing. And so this is about making a cognitive decision to strengthen and improve your thinking practices. So I've adopted Conway's law for my own to say that people who design systems will produce copies of their thinking and communication patterns. And again, this seems very obvious to me. And it is often my own ways of doing things that help me get me stuck when I'm trying to do different things. And so these practices are the most radical, I think, at a technology conference to suggest. But yet, I think, again, in the idea of expanding our skill set, something to at least add to the discussion about how we can practice thinking better. So writing is a something that I actually do workshops on for technologists, because when you're writing, you are doing systemic reasoning, and I don't mean fiction writing. I mean ideas, actions, theories, and it's a great way of making thinking visible, but also it forces you to create conceptual integrity. So often when I don't know what to do, I will just write. And I usually write by hand. I highly recommend writing first thing in the morning. It's a great way to figure out what you think so that you can respond better in circumstances when you're going to share your thinking. Modeling is the same. If you're more visual, I use whiteboards for everything all the time now. Moving sticky notes around. When I'm in a meeting, I open up a Miro board because it can be really beneficial for us to model the thinking rather than talk about it, because words can be tricky. We are using the word agile or agility, for example, and we don't all mean the same thing. Talking, discourse. By this I mean critical listening, learning from each other, building reasons together, or just talking out a problem with someone who understands it. And walking, and this actually is Cal Newport, who is a computer science professor and a best-selling author. He writes about deep work, and he's a big fan, he's not the only one for sure, of going for a walk when you're a bit confused or you need to think or you're stuck on something, that your other kinds of rhythmic movement, like going for a bike ride, is interestingly a great tool for helping to create flexibility in our thinking and become aware of what's going on for us. And the last is kind of radical, but making art. And the reason, or music, the reason I include this is whenever you're doing that type of activity, you're always deciding what to leave in and what to leave out. And that practice of prioritizing what to leave in and what to leave out is a big part of doing systemic reasoning. So bugs in our thinking produce bugs in our software system. And that when we're doing systems thinking, there's gaps in our reasoning between our thinking and the action. And in those gaps, a lot of weeds can grow. And so I'm going to give you a couple of examples of really common logical fallacies that you might experience in your day-to-day work. So in this example, Hollis recommends offloading complexity by using cloud native tools. And Breyer says, Hollis hates open source. So this is an example of straw man, where Breyer has made the argument about whether or not Hollis hates open source and shifted it away from the recommendation for offloading complexity. And it also takes a very extreme view. We see this in social media all the time. This is also an example of ad hominem, meaning that Breyer is responding to Hollis's recommendation by attacking him personally. Another example, Hollis recommends building a new capability using microservices with detailed reasons supporting it. And Breyer says, we tried microservices and it was a disaster. So past performance does not predict future results. Learning is central to systems thinking. So, you think of the iceberg. Why did the initiative fail? What were the patterns and structures that were acting on it? And how could the mental models change when you try this again? And then Hollis shares a new data model that suits the evolving circumstances. And Breyer says, this looks like a graph and graphs don't scale. So the problem isn't the assertion necessarily that graphs don't scale. The problem is the period at the end of the sentence. The burden of proof is on Breyer, not Hollis, to show why graphs don't scale. How did you come to that conclusion? And how is it relevant to this particular data model? So we see this so often where the burden of proof is shifted off the person making the assertion. And it's important that we are all engaging with showing the reasons that support our assertions. So think well together. So this depends on our ability to do systemic reasoning and metacognition. Those are precursors. And then you scale up. Rather than focusing strictly on your own skills, you're learning to facilitate systems thinking. And this is an improvisational comedy group. And one of the reasons that I like to use them as an example is because behaviorally, they mirror what we want, which is this process of yes and, where someone shares an idea and other people lean into it and do something with it. It has to be based on respect. And we are a very no culture. No. And no, that's a bad idea. No, change my mind. No, convince me. So improvisational includes rules that help people think well together. And these are the kinds of structures that we need in technology teams that help us create well together. And then another is collective modeling. So this is an example of event storming, but this is one of the many examples of collaborative modeling. And also there's so many good books now. Architectural Advice Process that is coming, Andrew Harmala is writing for O'Reilly. The Architectural Modernization by Nick Toon, Communication Patterns, which a very new O'Reilly book. In the ones you've seen here at the conference, collaborative modeling. So I'm encouraging you to dive into these. So the fifth one is to focus on relationship patterns. So Donella Meadows says, you think that because you understand one, that you must therefore understand two, because one and one make two. But don't forget that you must also understand and. And is the art and science of architecture. The system, says Russell Akoff, is never the sum of its parts. It's the product of their interaction. We're interested in how relationships produce effect in a system. And we're also interested in how time is involved. In systems, time will always be part of the equation, that we move from observing events or data to identifying the patterns and behavior over time, and then surfacing the structures that drive them. And we do this by focusing on patterns rather than trying to manage, control, command. Donella Meadows says systems cannot be controlled, but they can be designed and redesigned. And we're also often changing patterns while keeping the rest of the system stable, which is very hard to do. It's quite an art form. This is actually my favorite part because it's a constant puzzle. So the bonus last one is to be really good at building tech. Our technology expertise, of course, does matter, right? We need to be good in the tech. And when we're expanding our skill set into technology tools like ways of working with events, these all matter. So I would imagine what you can accomplish with these 5 practices plus technology expertise. I feel that it so much opens up opportunities for us to handle complexity and build hard things. So look for leverage points, be excellent at systemic reasoning, practice metacognition, think well together, and focus on relationship patterns, and be really good at building tech. So this is my book. It's an early release, so there's some of it out already. You can read along as I write it, or wait until spring or summer, depending on when this comes out. I'm done writing it in January, so we'll see. Also, though, in December, I start teaching a course on the O'Reilly platform. So, and then there's other opportunities on my website. Thank you so much for having me here to bring this to a close. It's such a delight.
Thank you, Diana, for the closing keynote. Was very interesting, very good things to learn about. And we had a few questions there, especially to how you get objective and avoid bias. So one thing was, what are the techniques for removing cognitive bias out of a recommendation to be as objective as possible? Yeah.
Yeah, I love that question. Oh, that's such a good question. Partnering. That over time, I develop relationships with people that can give me some feedback, and that their feedback will be, it's not intended to harm me, it's tended to help make it stronger. So this is why working with other people is so critical, because I'll tell you what, I don't see them. I just do not, even if I know I have a bias, I miss it. So other people,
Yeah.
building those relationships.
Yeah, and then there was a question which kind of fits one of the talks we had earlier. There's not the perfect solution. With the talk was about making trade-offs, find the right trade-offs. So even with properly researched reasons and well-supported reasons for multiple solutions, it's usually just a tip into the scale into the chosen solution. But this often comes down to opinions and subjective. Again, we have the objective or the subjective evaluation of recommendations recommendations in the experience. Are there any tips to make this as objective as possible, to removing the bias and get it going more in the objective way?
Yeah, and this keeping it well connected to the circumstances. So it's not every time, but most of the time. If we're going around in a circle, there are 3 recommendations, and we've had 743,592 meetings about this, and we're still going to talk about it again. Usually, we're not starting from the same why. We think we're solving the same problem, but we're not. And so I go back to the very simple elaboration of, why does this matter? Using language the organization uses, like the system's mission, the organization's missing. And then what are we doing to support that with our change? And 9 times out of 10, that's where the disagreement, that's where the disconnect is, that we are using all the same words, but we're not solving the same problem. And so getting clear on a shared understanding of the impact we're trying to have will help then strengthen the integrity of the reason. But also, I mean, there's not a right answer. There are 5 things we could do, and all 5 of them are probably good things to do. And so part of what we're doing too is this ability to not set in stone so much the having to come up with the exact solution, but picking the thing that we think will have the best impact and see if we're right.
One thing I wonder is, if I understand all of that and I listen to your talk, I understand, okay, it's not about opinion, it's about action, idea theory, but I work together with a team. So how do I convince the rest of the team to use this thinking as well? Else I will go with action and theory against opinions. And as you said, or we have someone such as Breyer who demolishes everything. How do I deal with that? And how do I convince the people that it will help us all if they
go
to your talk?
Yeah. So you cannot change anyone else's mind. We have this whole, it's someone's role to change hearts and minds, but you can't. People have to change their own mind. And I have never, when people are very entrenched in our usual way of thinking and communicating and power, you can talk until you're blue in the face, and you are not going to change them. So there are 2 things you can do. One is model the behavior. And what will happen is more and more people will see the benefit, and that will become louder than the loud voices that resist. That's as best you can hope for. And that doesn't always happen, but modeling it. And then second, you don't overcome doubt with systemic reasoning. You need to try something. So if you're really stuck and everybody's stuck in opinion, switch to talking about an experiment. Let's see. If you can get an experiment to happen, you can usually make more progress than more talking. So it's kind of like knowing when it's best to stop the bike shedding and just try something. But this is really a very, very hard thing. We're all kind of alone in the world with this, and we can feel like we're alone. I swear, I teach the workshops I teach and do it just so that we don't feel so alone in the world that's telling us that doesn't want to do this. So I think we need more time to figure out how to achieve critical mass with these types of practices, because they are very hard to take root in organizations.
Yes, thank you very much, Diana. It was really a great talk, and there was just again thanks, Diana, and the picture of the dogs. They got a lot of hearts in the chat over there.
Yay.
So very good content and very good presentation. Thank you very much, and
Great, thank you.
hope to see you again at our conferences.
Me too. It's one of my favorite events of the year, so I'm very glad to have been part of it.
Next year, your big book will be out, so you can talk about that.
Next year, the book will be out, and I'll be writing another one. We'll see.
Great. Thank you.
Thank you.
And with that, it would be great to have Milko. Yes, that's faster than I could say.
That's
like genie in a bottle.
Yeah.
So,
yeah. We have reached the end of the conference. Somehow it went very quickly today. I don't know. I would like to say a big thank to everyone who made this conference possible. First and foremost, you, the participants, and without your interest and participation, such an event would simply not be possible.
Yes.
Many thanks go to all the speakers for their great contributions. I also would like to thank the whole team of the IceQB and our partner Heise, who together put so much heart and soul in this conference over the past 4 days, and of course, long beforehand. And many thanks to our advisory board for their support and for putting together the program. And last but not least, many thanks to you, Reinhard, for the great cooperation. It was fun working with you.
Yes, I can say the same to you, Mirko. I'm pretty sure that's not the last time we're doing it together. A special thanks also goes out to Lisa, Alice, and Louis, who worked backstage, and Rebecca from Heise Academy. They helped us overcome some hurdles when there were problems with not getting the presentation up or a speaker coming in the last minute. That's always when as a moderator, you're really beginning to sweat. But you did a great job, Lisa, Alice, Louis. Thank you very much. And Mirko, yeah, I'm really looking forward to doing it again next year in whichever form it will be. And I hope we will get a lot of feedback from you. So for the participants, please tell us what you liked about the conference, what you didn't like, what you would love to hear about next year topics, or even technical things you want to change. And again, it would be great if we hear from you, if you want to do it again online, or if you prefer to have it in person. So there are several things. We will listen to you. That's one thing we can promise. We can't do it for everyone. You can't fulfill everybody's wishes, but it's always, if you don't wish for a thing, it can't happen. So thank you very much, and thanks, Mirko. And
Yep.
I hope you all liked the conference and enjoyed it as much as we did.
Yeah, and we would be delighted to welcome you back at the Software Architecture Gathering next year. And stay healthy and have a good time until then. And thank you for being here.